Today we're taking a look at section 9.2 on curves, polygons, and circles. And first of all, we talk about curves, and we have actually three terms that we'll be talking about as it relates to curves. First of all, whether or not a curve is simple. A simple curve can be drawn without lifting the pencil from the paper and without passing through any point twice. So an example of a simple curve and I know this isn't very straight, but would be a rectangle. A closed curve has a starting and ending point at the same place. It is also drawn without lifting the pencil from the paper. So the rectangle I drew, and let me make sure I close that corner there, the rectangle I drew is also a closed curve. All right. Third, if a figure is convex, then for any 2 points A and B inside the figure, the line segment AB will lie entirely inside the figure. So if I choose A and B anywhere, what we find is the line segment will always stay entirely inside the figure. That is also a convex figure. Let's look at some other figures and talk about, this is supposed to be a circle. It's a little bit lopsided, but it's close enough since my figures didn't transfer. This would be a simple curve. We drew it without lifting the pencil from the paper and without passing through any point twice. It is also closed and it is convex. As you can see, anywhere I choose my 2 points, when I draw the line segment between them, always inside the circle. Alright, so the first two figures we had met all three qualifications. Alright, here's a slightly different one. This is a simple curve because we can draw it without lifting our pencil from the paper and without passing through any point twice. It is a closed curve because basically where we started is where we end. It is not, however, convex because if I choose my 2 points here, the line segment right there is outside the figure. Okay, so it is not convex. So this one's simple, closed, and convex. This one is simple, closed, and convex. This one is simple and closed, but it's not convex. Alright, let's look at another figure. Like I said, none of my drawings transferred. This is a pentagon. Okay. And let me draw a couple more. Alright, that's a little bit different from what I drew on the original sheet, but that's okay. Because those didn't transfer anyway, I'm going to draw a few. Okay, and okay, so let's think about these. First of all, go through it and pick out the ones that are simple. Then go through and pick out the ones that are closed. And then last of all, go through and pick out the ones that are convex. So pause the recording for a few minutes and see if you can identify which ones are simple, which ones are closed, and which ones are convex. When you have your answers marked down, then restart the recording so you can check your answers. Okay, I'm assuming at this point that you have come up with your answers, and the pentagon will be simple, closed, and convex, so it meets all the requirements for all three. Our second one is not simple because we're tracing over a point that we've already entered, so it's not simple. We also can identify the beginning and the ending point and see they're very different, so it's not closed. And obviously we'd have a problem with 2 points. I'm not sure we even talk about it being convex unless it's a closed figure, a closed simple figure. All right, the next one is not simple because a figure 8 traces over itself. It is closed. We would have a problem again, just like here and up here. We could choose a couple of points, and that one actually worked out okay, but if I chose this one and this one, I think we'll go outside slightly. Okay. What about this next one? Well, it is simple. It is closed. It is not convex because if we choose a point here and a point here, when we draw the straight line between it, it goes outside. Alright, this one is not simple because it traces over itself. Not closed. It's hard to say it's convex because of the fact that we have openings there. I think we don't even talk about it being convex at that point. Alright, so our last one is simple and closed, and because of the fact that I can choose 2 points and it goes outside, it's not convex. Okay, regular polygons have sides that are equal, so that would be like an equilateral triangle, a square, a pentagon in which all the sides have the same measure, and I'm not very good at drawing that, a hexagon, and so forth. So all of the sides would have the same measure. And there again, I'm not very good at drawing them so they look equal. It also turns out they all have equal angles. So in this case, when we're talking, we know a triangle, the sum of the angles is 180 degrees. So each of those would be 60. Here each would be 90, and so forth. Okay, so all of the angles have equal measures as well. Now, we go back to our first polygon is the triangle. It has 3 sides, and there are 2 ways to classify a triangle. First of all is by angles, and we can have what is called an acute triangle. That is a triangle in which all of the angles are acute, which means they all measure less than 90 degrees. So that's one way we can classify a triangle, by angles. And the second way we can classify by angle is a right triangle. It has one 90-degree angle, which we designate with the little square there. So that would be an example of a right triangle. An obtuse triangle has one angle that is obtuse. Notice it wouldn't be possible to have 2 right angles because that would measure 180 degrees, so we wouldn't have any measure for the third angle. Likewise, with obtuse, remember an obtuse angle is greater than 90 degrees. So if we had 100 degree, for example, we couldn't have a second angle measuring 90 or greater. So we can only have one angle. The other two angles have to be acute. If we classify a triangle by sides, of course we can have an equilateral triangle. That's where all sides are the same measure. We can have isosceles, which is where two of the sides have the same measure and the third one's different. We can also have a scalene triangle in which each side has a different measure. So we have three different lengths there. Alright, from triangles we move on to quadrilaterals. And quadrilaterals will have four sides. The first one we have is the trapezoid. The trapezoid has one pair of parallel sides. One pair of parallel sides. Whoops, and it's erasing it. So let me highlight them. Okay, the other pair is not parallel. If you have both pairs of sides parallel, you have a parallelogram. If you have a parallelogram where one angle, which forces all the other angles to be right angles, you end up with a rectangle. So it's a special type of parallelogram. A square is a rectangle, so it also has right angles, where all the sides have the same measure. A rhombus is a parallelogram where all the sides have the same measure. So a square is a special rhombus. The sum of the angles of a triangle is 180 degrees. We mentioned that earlier. And finally, let me get my picture here so I